1991, Sparwood, British Columbia. A mining truck makes its final haul. 70% uptime, regularly exceeding rated capacity. Profitable operation for 8 years. Westar Mining retires it anyway. Not because it failed, because they only built one. The Terex 3319 Titan. 350-ton capacity, 20 meters long. The world's largest mining haul truck. For 17 years, it moved mountains. And when it stopped, the question wasn't whether it worked, it was whether anyone could afford for it to keep working. This is what happens when you build something nobody else can fix. If you're interested in the hidden economics behind industrial machines that changed the world, subscribe. We cover the stories nobody else tells. The equipment that worked, failed, or quietly reshaped entire industries. Late 1960s, the mining industry had a problem. Open pit mines were getting deeper, haul distances were getting longer, and the trucks moving ore from the bottom of the pit to the crusher weren't keeping up. The industry standard was 170 tons. Companies like Caterpillar and Euclid were pushing towards 200 tons. General Motors' Terex division decided to skip incremental improvements entirely. They designed the truck with 350-ton capacity. Not 10% bigger, double. The logic seemed sound. Fewer trucks means fewer operators, less maintenance overhead, lower cost per ton moved. Build one truck that does the work of two, and the economics should favor scale. GM's engineers started from a proven foundation: the diesel-electric powertrain used in locomotives. A 16-cylinder EMD engine generating 3,300 horsepower wouldn't drive the wheels mechanically. Instead, it would power an alternator, sending electricity to 4 traction motors mounted in the rear axle. No transmission, no clutch, just constant, smooth torque delivered through electric motors. The frame was welded steel plate. The rear suspension used 3 axles, 6 wheels total, to distribute 1.2 million pounds of gross weight. The tires alone were 12 feet tall. When the Titan rolled out of GM's London, Ontario plant in June 1974, it was unprecedented. 66 feet long, 25 feet wide, the largest off-road truck ever built. GM predicted production would begin soon. The truck would cost $1.5 million. Expensive, but justifiable if it replaced 2 smaller trucks. They were wrong about production. January 1975. The Titan arrived at Kaiser Steel's Eagle Mountain iron ore mine in California. This was the test. Prove the concept works and orders would follow. The Titan experienced frequent downtime. The sources don't specify why: mechanical issues, operational challenges, or simply the reality of running a prototype in production mining. But the truck worked enough to haul 3.5 million tons of material over 4 years. Here's what didn't happen. GM didn't receive orders for more Titans. Why? The coal market softened in the late 1970s. Mines faced pressure to cut costs. When budgets tightened, mine operators bought proven equipment: trucks with established service networks, predictable parts availability, known operational costs. The Titan was none of those. It was a prototype. Every repair required custom fabrication. Every breakdown meant calling GM directly. There was no fleet of Titans to share spare parts inventory. After 4 years at Eagle Mountain, Kaiser Steel returned the Titan to GM. Most stories would end here: a prototype that never reached production, a concept that proved too ambitious. But the Titan story was just beginning. Late 1978, the Titan was shipped by rail to Sparwood, British Columbia, Kaiser Steel's coal mining operation in the Kootenay Mountains. Different geology, different operation, different results. The coal seams at Sparwood were thick, and the overburden covering them was softer than California iron ore. The haul routes were shorter, and critically, the mine's excavators could load the Titan more efficiently than they could at Eagle Mountain. The Titan worked. Not perfectly, no machine does, but well enough that when BC Resources acquired the mine in 1980, they kept the Titan running. When Westar Mining bought the operation in 1983, they did something remarkable. They purchased the Titan from General Motors. $200,000 for the truck, $1 million for spare parts, $1.2 million total for a 10-year-old prototype that GM had stopped supporting. Why would Westar buy it? Because it worked. Under Westar's ownership, the Titan achieved over 70% uptime. It regularly held loads exceeding its rated capacity. For 8 years, from 1983 to 1991, the Titan was a productive asset in Westar's fleet. But it remained singular. Westar never asked GM to build another one. No other mining company ordered one. The Titan worked, but alone.
Here's the problem with being one of a kind. Every part is custom. Every breakdown requires fabrication. Every maintenance interval is unique. There's no shared knowledge base across a fleet, no economies of scale on parts inventory, no ability to cannibalize one truck to keep another running. By 1991, the Titan was 18 years old. It still worked, but the cost of keeping it working was climbing. Westar faced a choice: continue investing in a machine that would never have a spare parts network, or replace it with standard ultra-class trucks that could share maintenance infrastructure with the rest of the fleet. They chose standardization. In 1991, Westar Mining retired the Titan, not because it failed, because isolation is expensive. The mining industry had moved on. Caterpillar, Komatsu, and others were producing trucks in the 240-ton to 300-ton range, large enough to be efficient, small enough to be supported. These trucks sold by the hundreds. They had dealer networks, predictable maintenance schedules, interchangeable parts. The Titan had none of that. It had proven the concept, but the market chose manageable scale over maximum capacity. Teck Corporation acquired the Sparwood mine and faced the decision: scrap the Titan for metal value or preserve it. They chose preservation. The Sparwood Chamber of Commerce raised funds. Volunteers restored the truck. In 1993, the Titan was repainted in its original Terex lime green livery, placed on permanent display off Highway 3 and open to the public. Today, it sits in Titan Park. 12-foot tires still intact, frame weathered but solid, a monument to engineering ambition. Tourists stop, take photos, read the plaques explaining its specifications, its history, its singularity. The Titan is famous now, more famous as a roadside attraction than it ever was as a working truck. The Terex 3319 Titan worked for 17 years. It hauled millions of tons. It proved that a 350-ton mining truck was technically feasible. But feasibility isn't the same as viability. General Motors built the world's largest mining truck. They proved they could do it. What they couldn't do was build the ecosystem to support it. The mines didn't redesign around it. The parts network didn't materialize. The market didn't demand more. Economics chose a different path: fleets of manageable trucks over one giant, proven reliability over maximum capacity, standardization over singularity. The Titan didn't fail. It succeeded at being the biggest, but the market rewarded being the best fit. And now it sits in British Columbia, a reminder that engineering capability doesn't guarantee economic success. That proving a concept works isn't the same as proving the world needs it. GM built the Titan to change mining. Instead, it became a monument to the limits of scale. For more stories about machines that changed industries, from the twin-engine bulldozer the Army rejected to the tree crusher that cleared Vietnam, check the videos on screen. And if you want to see what we're working on next, subscribe.